All right, so let's take a look at this first problem here. We've got a regular hexagon, right? And then they give us a segment with a length of 10 going from one of the vertex to the center of the hexagon. Now we know it's a regular hexagon, so we know that all the sides are the same and all the central angles are also going to be the same. So first thing we need to do is we need to find the length of the side so we can get the perimeter. And then we need to find the length of the apothem, which is that perpendicular segment right there. So when we draw our apothem, that forms up our right triangle. So we're going to use that right triangle to find the length of this side and that side. Now how are we going to do that? Because we only have the hypotenuse here. All right, so we have to use one of the angles and our trig ratios in order to find these other two sides. Okay, so with a regular hexagon, remember that the central angles will all be 60 degrees, okay, and they're all the same. So that means that this angle here will be half that, all right, because if I draw one to the other vertex adjacent to it, that whole thing is 60. So I'm bisecting that, so now this is a 30-degree angle, okay? Now, let's expand that out over here so that way you can kind of see what I'm doing a little bit easier. All right, so there's my right triangle. There's my hypotenuse. There is my 30-degree angle. All right, so that means that this one has to be 60 because it's a 30, 60, 90 now. Now we're going to use our rules of 30, 60, 90 to find the length of the other two sides. I don't even have to use my trig ratios because it's a special right triangle. All right, so 30, 60, 90. Hypotenuse is 10. The short leg is always half the hypotenuse, so that means that this is 5. So that little segment right there is 5. And since the apothem bisects that side, that means this side is also 5. Those two are the same. So what's the side length of the hexagon? Well, it's also equal to 10. All right, so there's one piece of the puzzle we've got. Now we need to find this side of the triangle. That's this side right here. All right, that's our apothem. That's A, okay? So short leg, to get to the long leg, we multiply the short leg times the square root of 3. So it's simply 5 times the square root of 3. So that is the length of A. All right, now we have A. Now we have the side length. So we can find the perimeter and we can solve for area. So area equals 1/2 times the apothem, which we said was 5 square roots of 3. And that's times the perimeter, all right? So perimeter, the side length is 10, and there's 6 sides, so what's the perimeter? 10 times 6, or 60. All right, now I'm gonna multiply all this together in my calculator. Square root of 3 times 5 times 60 times 1/2. All right, try not to round until the very end. And then you should have ended up with an answer of 259.8. All right, so let's move on to the second problem. This one is a regular polygon, all right, but it has 7 sides. All right, apologize for my drawing. It's not easy to draw a regular 7-sided figure, but you get the idea. All right, but it does tell us that one side length is 3. All right, and so we want to find the area of this. All right, so we have the side length. So obviously perimeter is going to be 3 times how many sides, which is 7. So my perimeter is 21. All right, so I've already got half my equation that I need to solve for the area. All right, secondly, I need the length of the apothem, right? So that's the segment perpendicular from the center to one of the sides, okay? So central angle, again, is going to be the total divided by how many sides there are, all right? So my central angle is going to be 360 divided by 7, all right? So when I put that into my calculator, then I end up with a central angle of approximately 51.4, all right? Now, it's kind of a crazy number, so I'm just gonna leave it in my calculator for now, all right? And then we'll we'll address it when we get to it. So that's my angle there, all right? We'll just say approximately 51.4, okay? Now I'm not gonna round it off when I do the calculation, but for right now, I'm just gonna round it for explanation purposes. All right, that's that angle right there. So I need half that to find this angle. So let's expand this triangle out bigger so you can kind of see what I'm doing, and I can actually write inside the triangle. Okay, so there's my right triangle. All right, this side is A. All right, and then this is my side length. All right, so side length, remember, was 3. So that means that this one is half that, so that's 1.5. All right, and then this angle here is going to be half of that. All right, so for right now, we're just gonna call it 25.7. Okay, so there's that angle. So I took 360 divided by 7, and then I halved that, and that's that angle right there because it's being bisected. All right, so now I have an angle, I have a side, I need the other side. All right, so now I need to use my trig ratios to solve for that missing side. All right, so I've got this angle, this is my opposite side, and the apothem is gonna be the adjacent side. So opposite and adjacent, which one am I gonna use? I'm gonna use tangent, okay? So that means that the tangent of this angle, 25.7, has to equal the opposite side divided by the adjacent side. All right, so our variables on the bottom here, remember what we do there. We swap those two to solve for A. So A is gonna equal 1.5 divided by the tangent of my angle. Okay, so that's my apothem, right? So that'll give me the length of that. I have the perimeter. Now I'm ready to solve for area. So let's write it all out, and then we'll do it in our calculator. I'll show you how to do it to where that you can get the most accurate answer. Okay, so area equals 1/2, okay, times, all right, I want half of that angle there, right? So I want half of this angle right here. So I'm gonna use this, and I'm gonna take half of that, okay? So I'm gonna keep it in fraction form so that way I can get a more accurate answer towards the end here, okay? So I'm gonna do 1.5 divided by the tangent of half of this angle here. All right, so I'm gonna leave it in fraction form. So if I take half that, that will be 360 over 14 now. Okay, I just multiplied that by 1/2. That's all I did there. Okay, so I did 360 over 7 times 1/2. That's that angle right there. If I do it up in my calculator, then that'll end up with 25.7. Okay? But I'm leaving it in fraction form so I can do it at the end there. All right, that way I don't have to round. Okay, so let's go ahead and go through and do that. All right, so in the calculator, we're gonna do what's inside here first. Oh, sorry, and then we have to multiply that by our perimeter at the end. So let's do what's inside first here. So I'm gonna do 1.5 divided by, and I'm gonna use parentheses, 360 divided by 14, tangent equals. Okay, so I did 1.5 divided by the tangent of 360 over 14. Then I'm gonna do times 21 times 1/2, and I should have ended up with a final answer of approximately 32.7. All right, I'll do it in the other calculator in case you have one like mine, so you can see it if it types it out. Okay, so let's go through that one more time. So we're gonna do 1.5 divided by a tangent of 360 divided by 14. Oh, there we go. Close parentheses equals. Okay, so that 3.114, that's what that equals right there. Then I'm going to do times 21 times 1/2 equals, and there's my 32.7. All right, this next problem was pretty easy, probably the easiest out of the four, all right, because we're working with a square, all right? So a square is a regular polygon, right, because all the sides are the same, okay? So it tells us that the apothem is 12, okay? Now with a square, all right, I'm going opposite from the center, perpendicular to the one side. If I go to the other side, it should be the same. The apothem, no matter where I draw it, to what side, it should always be the same. So if that one's 12, then that means that one has to be 12, okay? So now, as you can see, the length, the full length of one of the sides of the square is just 12 plus 12, or 24. And since all the sides are the same, they're all 24, okay? So perimeter, I'm gonna add 24 up 4 times, so 24 times 4, that's gonna give me a perimeter of 96. It gave me the apothem, and that is equal to 12. So plug that into your area formula, 1/2 12 times 96, okay? Now, I could also do the area of a square. Because it's a square, I can just simply do length times width. All right, so I could also do 24 times 24. All right, so you're gonna get the same answer either way, whether you do 96 times 1/2 times 12 or 24 squared, you should end up with an answer of 576. Okay, so the last problem, we have a regular octagon, all right? But this time they give us the length of the apothem, all right? So it's right there, that's equal to 2. So half the equation already done for us, all right? Because area is 1/2 A times P, so we just need to find perimeter. So how do we find the length of that side? All right, well, we're going to use our central angle and our trig ratio to form up that right triangle and find that missing piece, okay? So if we form a triangle, all right, with a segment from the center to the vertex there, all right, I need to find this angle right here. That's gonna be half of one of the central angles, all right? And how do I find a central angle? I'm gonna take 360 and I'm gonna divide it by the number of sides, which in this case is 8. So the central angle is 45 degrees, and then I'm gonna bisect that or split it in half, so I'm gonna divide that by 2, and so this angle here should equal 22.5 degrees, okay? So now let's go ahead and expand our triangle out here so we can actually see what we're doing. Okay, if I can draw a straight line, there we go. All right, so that's this angle right there. All right, this is this triangle I just expanded out here. All right, this is your apothem, this side right there, and I want to solve for that side right there. X is going to represent half the length of one of the sides, okay? So to find perimeter, I'm going to take half of that, I'm going to double it to find the side length, and then I'm going to multiply it by 8 because there's 8 sides. So in other words, 8 times 2 is 16. So once I find X, if I multiply that by 16, that'll give me the perimeter, okay? Because there's 2 on each side. So perimeter, in this case, we're gonna say is equal to 16x. So we plug it into our equation. All right, so let's go ahead and solve for x. So that's the opposite side. This is the adjacent side. So I'm gonna use tangent again. So that means tangent of 22.5 degrees has to equal the opposite side divided by the adjacent side. Okay, multiply both sides by 2. Okay, so in my calculator, I'm going to do the tangent of 22.5 degrees, and then I'm going to multiply that times 2, and that's x. Okay, so we're going to say approximately 0.83. Now, I'm not going to round it or do anything with it. I'm going to leave it in my calculator for right now, all right? Because I need to take that, and I need to plug it into my area. So area is 1/2 times Potham, which is 2. Okay, these two are going to cancel each other out because 1/2 and 2 equal 1. And then I'm going to multiply that times my perimeter. So remember, perimeter is 16 times whatever that side is, which is x. So it's going to be 16 times approximately 0.83. So to find the perimeter, that will also equal my area in this case. I'm going to take this number in my calculator and simply just hit times 16. That's my perimeter. And since these two canceled out, that's also my area. Okay, so round that off, I should have got an answer of approximately 13.3.